Evening, sir.
Good evening, sir.
Sir,
Good
it
evening.
is is it audible?
Yeah, it is audible. Good evening, everyone.
Good evening,
Thank
sir.
you, sir.
Good evening, sir.
Shall I wait for others or everybody have joined?
Sir, 25 plus all have joined, but we have the strength of 40, and remaining 15 they are busy in their work and traveling. That's because they can't join,
Okay,
and
okay,
due
fine.
to network error basically. And after 15 minutes ki 20 minutes, sir, I will be allowing the juniors to join when there will be a session based on the aluminium and steel.
Okay,
For the
fine.
15 minutes, we will ask our doubts from our batch.
Yeah, sure. The point is, today, this discussion basically is a long-term discussion. 1 day or 1 hour is not enough. And then the point is, what I plan today, I will discuss about important question related to physical metallurgy and heat treatment, which are the most important topic in interview. So I will be talking about this physical metallurgy and heat treatment mostly today. Fine. Maybe some other day we'll discuss about iron making and steel making, and maybe some other things some other day. It's fine.
Okay, sir. Basically, steel based questions we could discuss today if
Steel based question.
is possible.
The thing is, no, steel based question. Today we'll discuss about physical metallurgy and heat treatment. That is the most important topic because recently one of your senior, you might know Vedant. He is one of my
Yes, sir.
favorite guy. Yeah, he's one of my favorite people. So Vedant got placed in Bark recently. He already got placed in Hindalco. He got a good rank in gate examination, and thirdly, he got placed in Bark also. He's in close contact with me always. So after the interview from Bark, he was very disappointed because he cannot able to answer a lot of questions. Anyways, he by the way he answered a lot of questions, but still he was disappointed and he was talking to me. So what I have got from that, physical metallurgy and heat treatment are one of the most important topic they're asking, and extractive also they're asking from different backgrounds. And even if in your interview like Hindalco or Nalco, sorry, Hindalco, Aditya Birla, I mean, sorry, Vedant, or this Tata Steel, JSW, they also ask you on the questions from heat treatment and physical metallurgy. So today we'll discuss about physical metallurgy and heat treatment. But if you have any question related to iron making, steel making, I can answer it, no problem. If you are ready with those questions, I can answer it. There is no issue. Okay,
Okay, sir.
fine. You can start with your doubts. You have any questions? First of all, I will take it. Then later I will discuss about the question and answer. And I hope this meeting is recorded because you cannot able to remember everything what I will discuss. So better you record it so that I can upload it in the YouTube and you can watch it anywhere you want. Just before the interview, you can watch it also.
Okay, sir. I will make it sure.
Okay, fine. You have any questions, guys? You can ask me. By the way, your summer internship is over, I think.
No, sir. It is just in progress. Uh,
I think already you have crossed 40 days of vacation.
No, sir, not yet. So we are still
Okay, fine.
like continuing our
Okay,
internships.
fine. How was your projects going there?
so we are going to start the project basically after this week, uh, based on OES in Aditya Birla Cast House Hindalco.
Oh, yes, optical emission spectrometer.
Yes, sir.
Okay, fine. Okay, you guys have any questions or shall we move to question answer directly? You're feel free to ask any silly questions also. There is no issue.
Good evening, sir.
Yeah, Divyanshu.
Sir, I was just asking that interviewer will focus on what we have learned in these 4 years or on our internship.
I think you have missed my last meeting. Is it so?
Sir, I had actually joined it, but I'm getting very different opinions
Okay,
from
fine.
our
Fine,
seniors.
Divyanshu, it's fine. The point is, the first question they always ask is about internship, where you have did your internship, and they ask questions on basis of that. Fine. The second one is they will ask questions from your minor project. And the third, they will ask from the questions from textbooks or like whatever you learned from the class. These are the three important pillars. The first one is the internship, the second one is your minor project, the third one is the subjects. Suppose you have a very good CGPA, for example, then they won't ask you questions from the class, whatever you taught, if whatever you read in the 4 year course. They will simply ask you questions on the basis of minor project or your internship. That's all. Sometimes they also ask you your favorite subjects. And even it happens sometimes. Suppose you'll tell your favorite subject is physical metallurgy. They won't ask you on physical metallurgy, they will ask you on iron and steel making. This also happens. So you cannot predict. But these are the three important pillars. They will ask questions from this part. I think I am clear to you, right?
Yes, sir. And sir, if we have to categorize subject-wise priority,
Yeah, priority. Yeah, if you are sitting for any core company, basically, it may be your steel industry or aluminum industry. The most important subject is introduction to physical metallurgy, heat treatment, and second comes iron making and steel making. So these are most important subjects: iron making, steel making, introduction to physical metallurgy, and heat treatment. Apart from that, suppose somebody have did internship in, for example, like cast house. Somebody is saying cast house, right? So they may ask you about solidification and casting, or that is I don't remember exact your subject. That is maybe in our time it was solidification and casting, or casting and solidification. They may ask you from questions from that subject, huh? Suppose somebody will tell I did my internship in hot rolling and cold rolling mill, so they may ask you questions from DBM, deformation behavior of materials, or maybe from metalworking of metallic materials. These are the two subjects you have in your syllabus, you can see, right? So mostly physical metallurgy, heat treatment, iron making, and steel making. These are most important subjects. For Aditya Birla and Vedant, they can ask you from non-ferrous also. Principles of extractive metallurgy and non-ferrous extractive metallurgy. These are more important subjects. Anything else you want to ask?
no, sir. Thank you, sir.
Sir, they will ask about the project basically, or they will ask that based on their own way, which subject is your favorite, or totally, if you have done internship in Aditya Birla, will they ask based on the Portland too, or only cast house?
Suppose you have clearly mentioned in your CV that I have did my internship in Aditya Birla at this cast house. They will ask on the cast house itself. Otherwise, they will ask to introduce yourself. So while introducing yourself, you can add this one. I have did my internship here. So they will continue with that only. They will ask mostly from the cast house. But my suggestion is you should have few knowledge on entire industry at least. At least 1 2 day you roam every part of the industry, but spend more time in a particular area. So my point is, if you're doing internship in cast house, they will ask on the basis of cast house and related to that.
Okay, sir. Thank you.
Anybody have any questions? Other?
Sir, there is one question on behalf of Mona Lisa Sahu.
Okay, fine.
Because then her mic is not audible and she's in a crowded area.
Okay, okay, fine.
So, on behalf of her, I am asking that aluminum companies basically do they ask based on questions based on iron making and steel making?
Yeah, this is a very important question he asked. The point is, I told you, na, suppose uh, they'll ask what is your favorite subject, for example. You will tell that my favorite subject is, for example, non-ferrous extractive metallurgy, or you say principles of extractive metallurgy, because you are focusing on aluminum industry. That's why you are saying maybe. Suppose Aditya Birla is going to come. So you are preparing for aluminum extraction, copper extraction, principles of copper extraction, principles of aluminum extraction. So you will be completely prepared with principles of extractive metallurgy and non-ferrous extractive metallurgy. But they will not ask you from that. They can ask you on iron making and steel making. This happens many times. Why? Because they obviously know that you know this company is going to come. Obviously you'll prepare according to that, but it doesn't mean that you didn't prepare other things, because iron making, steel making are very important subjects, right? Physical metallurgy and heat treatment are the very important subjects in that they are the pillars, you can say, pillar of the uh, metallurgical background, right? So you need to prepare whole subjects. Like, as I told again, introduction to physical metallurgy is important, heat treatment is important, iron making is important, steel making is important, principles of extractive metallurgy and non-ferrous extractive metallurgy. These are the most important subjects. That's why I'm saying if you have enough time, you can go through my YouTube videos. Everything is properly explained. A simple thing is explained there. You just start watching, you got to know that. Seriously, I'm saying you can talk to your seniors also. You can talk to your seniors. They have prepared from my YouTube channels only. They have attended the class properly. I remember they have class notes also, but even if, I'm sure that you cannot remember everything in the class itself. That is the point why I have uploaded the things on YouTube. You can watch it anytime, anywhere. Okay, any questions? Further questions?
Yes, sir. I have a question.
Yeah, Purva.
So, is the knowledge of material characterization, like we perform XRD and SCM and all in our minor projects, is that important? Like, do we need to explain them if they ask?
Yeah, it is very important. The point is, if you remember, last time I visited that Drabya and departmental function, I
Yes,
remember.
sir.
Yes. So one of your seniors, I remember, he is also one of my favorite people, I can say. Uh, Patro, yeah. So what he told, nowadays, this Aditya Birla, this Tata Steel, they are giving chance to the BTech people in R&D, research and development. Why? Because they got to know that in VSSUT, the students are very good. I mean, in terms of teaching and knowledge, they know better. Right? The VSSUT students learn better because our faculties are very sincere. I don't know if what is your opinion about that, but as per my knowledge, our faculties are very sincere there. The classes are running in a proper sequence, and maybe they are taking 30 to 40 class. You know that, right? So you have a proper knowledge on knowledge. That's why they are taking in R&D. So if you're working in R&D, so characterization is a very important subject. So suppose in Aditya Birla they will ask you what is your favorite subject. You can also say my favorite subject is characterization. So they will ask you about XRD, SEM, TEM, or some optical microscopy. If you can able to answer very nicely, maximum chance is that you can also get directly R&D after BTech. You can get placed in R&D directly.
Yes, sir.
Yeah,
Thank you, sir.
welcome. questions. Okay, fine. I think there is no other questions from your side. Okay, today we'll discuss about this important questions related to IPM and heat treatment. Huh? The first questions they basically ask is, do
Sir,
you know? Yeah.
sir, just give us 5 minutes so that all the juniors are joining in the
Okay,
series
fine, fine. Yeah,
basically.
sure. So in between that,
After,
if you have any questions, you can ask. Yeah.
yes, sir. Subhendu Pradhan has the question, sir, what is a boiler operator?
What is boiler operator? Boiler operator means, I think what you are asking. I think you are asking about power plant. Boilers simply means where there will be boiling. Fine. What they will boil the water, they will convert the water into steam. Then this steam will be bombarded to the turbine blades, and the turbine will rotate, and you'll generate electricity. So maybe boiler operator means same who operate the boiler. I think you understood, Suvendu. Are you there?
Hello, Subhendu.
Yes, sir. Sir, some of metallurgy students are placed in sir boiler operator. So I was asking about that.
Okay, is it so? I don't know. I don't have any idea about that because I don't know how they are giving metallurgical people in boiler. Boiler basically run by mechanical and electrical people. Understood?
Yes, sir.
Because they design the boiler. Metallurgy people, they can study the failure analysis, how the boiler get failed. You might have a subject, I know, I'm not sure. You might have a elective subject in higher semester, failure analysis. So suppose your boiler got failed, then you need to analyze how the failure occurs. We metallurgy people can identify the reason behind the failure.
Yes, sir.
So you understood what is the boiler operator? You understood now?
Yes,
Shall I
sir.
repeat? Yeah, okay, fine. Because if you go to, for example, Aditya Birla, I mean Hindalco Industry, you can see they have boilers. They have captive power plant. Captive power plant means they have their own power plant. They bring coal. That is a coal fired power plant. They bring coals and burn the coal and heat the water in the boiler, and it will become steam. That steam will be traveled through the pipelines, and finally it will strike the turbine blade. Then the turbine will start rotating. When the turbine rotates, the shaft connected to the turbine will rotate, right? And the shaft is connected to the generator, so it will generate the electricity. Hmm. And finally, this electricity will be utilized for aluminum production. You know, Hall Herold process. We need
Yes, sir.
electricity to generate aluminum out of aluminum. Fine.
Yes, sir. Thank you, sir.
Yeah.
Sir, there is a question for the lab jobs, basically like in the bark or
Mhm.
in the some lab jobs. What type of
Okay.
subjects shall we have the grip?
As I told in the bark, they will ask you questions from different subjects. Like what Vedanta told me, they ask questions from starting from introduction to physical metallurgy. They goes to heat treatment. They ask principles of extractive metallurgy. They ask non-ferrous extractive metallurgy. They ask characterization. So because you are going to be a scientist after 1 year of training, so you should have a good knowledge on everything. So they will mm, they will see how much knowledge you have in different subjects. But if there is any vacancy for particular scientist post, then they will ask on particular subjects.
So we have heard that Aditya Aluminium uses AP36 technology. So what basically is this means AP36 technology?
Sorry, can you repeat again?
So we have heard that Aditya Aluminium uses this AP36 technology.
AP
Yes, sir.
AP 36 technology you are saying, na?
Yes, sir. So, what is basically this AP36 technology? Can in like
No, I don't have much idea on that.
yes, sir.
Okay, I will get back to you if I have something on that. Fine.
Okay, sir. Okay,
Yeah,
sir.
there are different technologies they are doing, maybe to
Yes,
make
sir.
it automation, maybe sometimes, right? Because
Yes,
nowadays
sir.
the plants are operating on automations. They don't
Yes, sir.
need much people to operate it. So it may be particularly related to some automation. I'm not sure exactly. Maybe related to automations.
Yes, sir.
Maybe related to productivity, more production they want. So they are using a particular technology which will give you more productivity. In less interval, you can produce more. That may be
Okay,
one
sir.
of the reason, or maybe making automation, everything.
Okay, sir. Okay, sir.
Yeah. And each technology have their own benefits, like nowadays we are moving towards sustainability. I don't know you people have heard about this term or not. Sustainability.
Yes, sir.
Yeah, so we all are moving towards sustainability because we want to make the process more efficient. In addition to that, it should generate less pollution or no pollution at all. Or we are going to recycle the things. We don't want to generate any kind of waste which are harmful, right? No influence, no hazardous influence we are generating, right? So production will be there, profit will be there, but we don't want to harm our environment. That is called sustainability. So maybe this epi technology is giving good sustainability, I think. More productivity with good sustainability.
So one more question I have.
Yeah, yeah.
So what will be the interviewer he will be focusing on? Means he will see that we have a overall knowledge on metallurgy, or he will go to the depth of it.
Sorry, can you repeat?
Sir, what will be the interviewer will be focusing on? Means our depth of knowledge on the topic, or
Yeah.
our overall
Okay,
approach.
fine. The point is, in interview, they don't ask very tough questions. If I am an interviewer, I don't ask you very tough questions. Seriously, they ask very very simple questions. If you're giving the answers properly, they will go into the depth. Again, you are answering that questions efficiently, they will go into the depth. They want to see how much you know. It doesn't mean you have a very depth knowledge, but at least you know the basic things, right? Suppose as a metallurgist, I may ask you what is the difference between aluminium and iron. This may be a very simple question they can ask, right? What is the difference between the yield strength of iron and yield strength of aluminium? How you can differentiate it? Or what is the difference between cast iron and steel? These are very simple questions they will ask. If you can answer it properly, they will ask in the depth. Suppose you can answer it properly, difference between cast iron and steel, they can ask you what are the different type of cast iron, what are the different kind of steel. If you can able to answer it, they can go into the depth. How much weight percentage of carbon in this particular kind of steel? What is the alloying element present in that kind of steel? What is the application of that kind of cast iron? So in this way, they enter into the depth. My point is, never bluff the interviewer. If you don't know, if you don't remember, just simply say, "I have studied that in my BTech, but right now I cannot able to recall it. But if you give more time, then I can recall it. I can otherwise I can after this interview I can check it. But I know something about that. But don't bluff if you don't know the exact answer." Or if it is completely new to you, just say it is actually I didn't have heard about this is the first time I'm hearing this one. Maybe I missed this one, you can say. I missed this particular topic. So no need to bluff. That is a negative impression.
Okay, sir. Thank you, sir.
So basically, in this recent interview, Tata means the answer will be the next question which I have experienced in my last interview.
Okay, you want to share your experience? Okay, you can share it.
Like in every question, if I'm answering something, in that answer they will extract some question and they will ask. The
Exactly, exactly.
answer becomes the question.
Whatever I explained, same way. Yeah, yeah. You can continue. Yeah.
Basically, the subject was based on the material testing and heat treatment.
Okay. Mm-hmm.
And recently in our labs, there are lack of equipments, that advanced equipments, and in their labs there are technology-based advanced equipments which we lacked in our labs. So we failed to answer in because we are in the initiation of the sixth semester in that time.
Okay, fine. You can, yeah, this is one of the fault we have in our university, you can say simply fine. But the point is, as per my knowledge is concerned, suppose they have asked you 10 number of questions, 5 number of questions will be basic questions, 5 number of questions will be maybe on the basis of advanced level. So at least you can give 5 questions answer. That is enough to
Yes,
get
sir.
selected. Yeah.
I felt that my answer was wrong completely in that the management question, HR question, HR round question,
Okay, fine,
that what
fine.
are you planning in the next years? I said that I will be planning for management course after
Okay.
having my job experience of 2 years or 3 years. That was my fault.
It's fine. It's fine. It's happened. Okay, fine. I told you already, guys. Did you
Mm.
check that particular videos related to placement? It is already there on my YouTube. You just watch it. I have explained everything, how to prepare for interview, how to prepare for HR interview. Basically, as Avinav told, he cannot able to answer properly about the HR interview. HR interview is very important. Even if you have very good knowledge in this core part, but if you cannot able to answer properly the HR part, you are not selected. I'm 100% sure. So that is very very important. Just if you still didn't go through that video, just go through that video. It is maybe 30 minutes to 50 minutes, I don't remember exactly. Just go through that video, how to prepare for interview, how to prepare for HR interview, technical interview, and group discussion. I have explained everything, how to dress up, everything is there. If you want, I can share you the link. Otherwise, it is there in my YouTube channel, you can just check it.
Sir, that is one question from Jyotirmay Sahu, that if a student fails to get internship in aluminum-based companies,
Mhm.
then he or she, how they will prepare for aluminum-based companies?
It's fine. I already have told you about this one. Like, suppose you simply say they can manipulate you simply that you have fitted for this aluminum company, but you didn't did your internship in any aluminum industry. Why? They can ask you this simple question. You simply say, "Sir, I don't have any connection nowadays. We need to have some reference to get internship. So I don't have any kind of reference. I tried hard to do one of my internship there, but I don't have any kind of reference. None of my close friend have any reference, so I cannot able to do it. I have a reference in that company, so I did it, and I did it in a well manner. So it's not a big deal. If you want, I can share you the link of that Hello. Hello.
Yes, sir.
Hello,
There
hello,
was
sir.
something wrong with my network. Now it is fine. Am I
Yes,
clear?
sir. It was not audible in between.
Okay. Shall I repeat it or you got the point?
No, sir, you could repeat it again so that we
Okay,
could
the point
record it.
is, yeah, yeah. As I told, there is no need to concern about that. You simply can answer. I cannot able to do my internship in any aluminum industry because I don't have any connections there. I don't have any reference there. I tried my best to do there, but since I don't have any reference, I don't have any contact, so I cannot able to do my internship there. But I tried hard, but I got have connection in RSP or some steel industry. I did it. So there is this is not a matter of concern. So they will ask questions from steel making, iron making, or where you have did your internship. So though there is no barrier for your selection. Is it fine?
Yes, sir. Sir, could we consider the report based on the NALCO plant? Basically, in the smelter plant, we have done internship in Portland.
Okay, fine.
And could we mention it as a project based on the reports of the Portland in our CV?
The point is doing internship and doing a project is a different thing. If you really did any project, you have solved any problem, ongoing problem, or you did a particular project there, then mention it. I did a project there. But if you did only internship, you have roamed there, you learned the things, then no need to write any projects. Simply write, I did my internship in this plant in this particular area for this particular days. That is enough.
Okay, sir.
Because
Sir, all the
while you are in internship, they will give a certificate if and clearly mention you have did a project also. But if you didn't do any project, they will write simply you have did internship here for this much days from this date to this date. That's all.
sir, we have the juniors right now with us.
Okay.
Could we allow them to ask those questions from their side, or will
Yeah, sure,
proceed
sure.
with
Yeah, yeah, yeah.
our?
Okay, fine. They can ask questions. No issue.
Sir, I would ask Gyana to ask you the question
Okay, okay, fine. Yeah, no.
from the pre-final year.
Good evening,
Gyana,
sir.
please.
Hello.
Hello.
Sir, am I audible?
Yeah, you are audible.
Good evening, sir.
Good evening. Yeah.
Sir, my question is that is it required to do any internship at any laboratory like NML or ICSR?
Yeah, it's very good. It's very good. You can do. There is no issue. You can learn a lot of things. But whatever I suggest mostly people, you try to do one internship in one industry and do
Yes, yes.
another internship in any labs or in any IITs, NITs, or some good research institutes. It is best. But if you really want to go in any core company, you want a job where you want to work in a core company, then if you're doing internship in industry, that is good also. There is no issue. Right? But if you have interest in both research or higher studies as well as in the core company, then you can do both.
Okay, sir. Sir, one more question is that, sir, in the month of May, I was done internship at NALCO.
Okay, fine.
Yes, sir. So at there, one of our guide is Himanshu Bhushan Rautray. He's
Okay,
the deputy general manager.
okay,
So, sir, he was assigned us to do a project on uh, alloy
okay,
AL356.2. So we have researched on that. Since
fine.
our
Very good.
group was research on that.
Very good, very good.
So we have get a project certificate on it.
Nice,
So,
nice.
sir, is it yes, sir. So is it valuable, sir?
Yeah, yeah, definitely, definitely. Okay, fine. You people didn't interact with me, that's why you don't know. If you are going for any internship and you are doing a project, that is the added advantage, always. Because you're going to solve a real life situation or real life problem, right? So doing internship
Yes,
is
sir.
fine, but if you're doing internship with a project, that is more added advantage. You'll be in the more
Yes, sir.
advantage
We are
side. Yeah,
Yes, sir. We have done internship with one project, sir, at
that is
Nalco.
very good. That is very good. Okay, fine. You are developing a particular alloy, right? Which series
Yes,
it
sir.
is basically aluminum? What you call?
So it is aluminum alloy AL356.2.
AL356.2. Okay, fine.
Yes,
Which
sir.
series it is? 1000 to, sorry, it is not 1000. Which series? Like 2000, 3000, 4000, 5000. The different series of aluminum alloy.
Sir,
Do you have
it
any idea about that? Any alloying element? What are the alloying element in that particular aluminum alloy? You do know? What is the composition?
yes, sir. I have the
You did a project, but you cannot able to answer it. How this is possible? At least you should know the composition. I'm not talking about any particular amount, but what are the alloying element present? Like zinc is there, or maybe silicon is there, or maybe magnesium is there. These are the alloying elements we add in the aluminum, right? Magnesium,
yes,
silicon,
yes, yes.
zinc,
It's
copper.
silicon. Yes, sir. It's there, sir.
What is that? Silicon.
Yes, sir. Silicon content is there.
Okay, silicon and what else? Only silicon.
No, sir. Silicon, then magnesium
Okay, silicon
is there.
magnesium alloy. Okay, fine. Maybe this is a
Yes,
cast
sir.
alloy, I think.
Yes, sir. Silicon, magnesium. Uh, Silicon is the sir most weightage
In a
in that.
prominent amount, higher amount, you are saying, dominating amount.
Yes,
Okay,
sir.
fine. That
It's
is
of
called principal
6.5.
alloy.
Yes, sir. It
That is called
about 6
principal
to
alloying element.
7%.
Okay, okay, fine. This is a cast alloy.
Yes, sir.
Silicon means cast alloy.
Cast alloy. Yes, sir.
Yeah, you cannot forge it or roll it. You can only cast it.
Yes, sir. It's also contain iron also. Iron is about 0.15%.
Okay, fine. Do you think, what is the application of that particular alloy? Are they using for any particular automobile sector or any other applications?
Sir,
You
it
have any
has
idea?
good strength. So it will be means it is applicable for making the planes and helicopters like.
Okay, fine. Automobile or aerospace industry, you are saying. Okay, anyways,
Yes,
fine.
sir. Sir, in cars also we can use that.
That's why I asked. It is in for automobile industry mostly,
Automobile
not for
industry. Yes.
aeroplanes because aeroplanes they need lighter weight also, no. But silicon, if you add iron, if you are adding, then iron is having high density, no. It will increase the density. Anyways, maybe I'm not sure, but for automobile industry maybe.
Yes, sir.
Okay, fine. Any other people want to ask any question? Third years. Maybe this is the first time I'm interacting with the third years. So you can ask any silly questions you have, no issue. I hope you people have got the links for my YouTube channel, right?
Yes, sir.
Yes.
Third year, I'm
Yes,
asking to
sir.
third years. Yeah. Did you start watching those videos? It is always better to prepare early. Okay, fine. Any other questions you have, or shall I move to discussion?
Sir, let's start the session.
Okay, okay, fine, fine.
Le-
Okay, so
In the end of the meeting, if they will be having question, then they will be informing in the chats. I will make sure to from you that you will answer all the questions later.
okay, okay, fine, fine. Hello, am I audible?
Yes, sir, audible.
Yeah. So today's main objective of this discussion is we are going to discuss about question related to introduction to physical metallurgy and heat treatment. These are the most important subject the interviewer will ask you during your placement, during your viva, wherever you go. If you go for any off campus also, if you go for any bark interview, or maybe you'll go for any higher studies interview like doing MTech in IIT or IC Bangalore, anywhere you'll go, they will ask these basic questions. It may not be 100% accurate, but what I feel, these are the important questions, right? So the first question is, draw iron carbon phase diagram. This is the one of the simplest question, or the first question come into mind of a metallurgist. Do you know iron carbon diagram? You obviously need to say yes. Then they will ask you to draw iron carbon diagram. So you go through my channel, you just watch how to draw a iron carbon diagram. I have explained in a very simple way. You no need to remember, no need to mug up the things. You just see how I have drawn the iron carbon diagram. What is the first step, second step, and how to remember all the things. Fine. So this is the most important question: how to draw iron carbon phase diagram. Just check it. The second question is, what are the invariant reactions in iron carbon phase diagram? Then they will ask you, write or explain all the invariant reactions happening in iron carbon phase diagram. Anybody remember this answer? What are the invariant reactions happen in iron carbon diagram?
The peritectic reaction, eutectic reaction, and eutectoid reaction.
Yeah, these are the most important three reactions: peritectic, eutectic, and eutectoid. So you need to show them in that diagram. You need to show them this is the peritectic reaction happening, this is the point where eutectic reaction is happening, and this is the point where eutectoid reaction is happening. You need to show them. You need to show them the weight percentage of carbon. You need to show them the temperature, at what temperature it is happening, after drawing the diagram. If you can able to do it, they will be very happy. Fine. Okay. Further discussion if you want. Then if you remember peritectic reactions, basically what happens here? Liquid plus gamma. I remember liquid plus delta give rise to gamma. Right? And in eutectic reactions, what happens? The liquid will decompose into gamma and what is that? Gamma and liquid will decompose to gamma and cementate. I think, yeah, lead fine. And in eutectoid reactions, what happened? Eutectoid reactions, gamma will decompose into alpha plus ferrite. Sorry, alpha plus cementite. Yes. You need to write the reactions also. These are important, fine. The third question is, acha, what is perlite? Okay, fine. What is perlite? What is martensite? What is benite? What is ferrite? What is ledeburite? What is austenite? All these things are there in iron carbon phase diagram, apart from martensite. So you need to explain what is the definition of this. You need to remember. Fine. What is ferrite? What is perlite? What is benite? What is martensite? What is ledeburite? What is austenite? Anybody remember these things? What is austenite? Anybody remember?
Sir, it's gamma phase iron.
Yeah, it's gamma phase iron. That's fine. You can say austenite. We represent it by gamma. It's gamma iron. But if carbon is also there, then it is a solid solution of carbon in gamma iron, you can say. Right? That also you can say. What is perlite? Anybody remember? Alpha plus cementite, right? Ferrite plus cementite will be there together. It is a mixture of phases. Perlite is a mixture of phases. Or perlite is a bicrystal, you can say. One crystal is alpha ferrite and another crystal is cementite. That's why I'm saying go through the lectures. You'll understood everything. What is martensite? Anybody remember? Martensite. Martensite have BCT structure, body center tetragonal. Fine. It is one of the most hardest phase in iron carbon system. Not the most hardest, but one of the hardest phase, you can say. And it is a non-equilibrium microstructure. You have to remember. Martensite is a non-equilibrium microstructure. Right? Benite, Benite is also again a mixture of phase, alpha and cementite. But it is not lamellar like perlite. Perlite is lamellar, but benite is not lamellar. They have two kinds of benites, upper benites and lower benite. Okay, ferrite, anybody remember? Ferrite is simply iron. Pure iron is also called ferrite or alpha iron, we call it. Right? Or iron containing very little amount of carbon, negligible amount of carbon. You can check the percentage, exact percentage. Ladyburite is a mixture of phase again. Anybody remember what is ladyburite phase? Gamma plus cementite, fine. Gamma is one phase, that means austenite plus cementite. Okay, fourth question is what is the difference between steel and cast iron? Yeah, this is one of the basic question. Difference between steel and cast iron. Anybody remember? Steel and cast iron difference. This question also comes from iron carbon phase diagram. Fine.
So percentage of carbon basically varies in both of them.
Yeah. What is that limit? What is the limit? How you will differentiate it?
So a cast iron contains more than 2%
Okay, fine.
carbon,
Mhm.
whereas that the steel contains 0.1 to 0.6 percent carbon.
No, it's not the right answer. Anyways, steel means steel and cast iron both are in iron carbon system. Iron and carbon both are there, right? But the difference is the amount of carbon. If carbon is below 2%, it is called steel. If the carbon is above 2%, it is called cast iron simply. And cast iron are very brittle. Why? Because the weight percentage of carbon is very high. Higher is the amount of carbon, higher is the brittleness, higher is the hardness, right? Cast iron are brittle. You cannot roll it. You cannot force it. You only can cast it. You have a molten cast iron, you cast it, solidify it in a mold to give a shape. But if you have a steel, you can do anything. You can do rolling, forcing, whatever mechanical working you want, you can do because the amount of carbon is less. Steel is ductile, malleable, also hard, strong, tough. But cast iron properties, it is brittle because of higher amount of carbon, and it only can cast. You cannot roll it, force it because of its brittleness property. And if you remember, higher is the cast iron, higher is the cementite phase. Cementite phase is very brittle in nature. You have to remember the property of each phase. That is very important. What is the property of ferrite? What is the property of martensite? What is the property of austenite? What is the property of martensite? As I told, you have to remember all these things. Okay. Anyways, what are substitutional and interstitial voids? Sorry, interstitial. What are the interstitial voids? Basically, in carbon, in iron carbon system or in any system, that is very important. Huh? What are the interstitial voids? Interstitial voids means it's simply the voids in between the atoms, adjacent atoms. When you are doing stacking of atoms in any material, maybe steel, maybe iron or anything, there will be certain kind of empty space between the atoms. That is called voids. Those are interstitial voids. Anybody remember where carbon will go if you add carbon into iron system? Where it will go and stay? Interstitial voids only. They'll go into the because the size of carbon atom is very small, and interstitial sites voids are also very small. It can go into that. But if you add chromium into iron, where it will go? It will go. Anybody can anybody answer it? If you add chromium, if you add nickel into the iron, where it will go and stay in the
Substitutional.
where?
Sir, substitutional.
Substitutional, very good. Because the size of nickel, chromium are comparable with the iron size, iron atom size. So it will substitute the iron atom and sit there in the lattice site, you can say. And simply you can say in the lattice point or lattice site. But if you add a very small atom like boron, nitrogen, where it will stay? Can you tell me? If you add nitrogen, boron, where it will go and stay?
Interstitial.
Interstitial, because they are very small atom. They can occupy the interstitial sites. So because of that thing, there is a phenomena also, if you know. Yield point phenomena. Have you heard about this point? Yield point phenomenon. That is a very important question they ask in interview. What is the yield point phenomena and how it occurs in the steel? Because of this interstitial sites or interstitial points, interstitial atoms like carbon, boron, nitrogen. Those are called quaternion atmosphere, if you remember. Anyways, why pig iron melts at lower temperature, whereas iron melts at higher temperature? Anybody remember the melting point of iron? What is the melting point of iron? You are a metallurgist, you should know this. Already
1536.
15? 1536.
1539.
15, yeah, okay, fine. If you go to different books, they have different numbers, values. You can, if
Yes.
you can say 1538, 1539, that's also fine, no problem. 1538, 1537, 1539, that's fine, no issue, no problem. But what is the melting point of pig iron? Already you have studied iron making, no? Yes, you can answer it. This question also related to IPM, huh? That's why I'm asking.
For around
See,
1100 degree.
1149.
1149? Are you searching the Google or what? It's pig iron. Pig iron means it is impure iron. It contains a lot of impurities. It's not a pure iron. So its melting point is variable. It's not a constant melting point. It's an alloy, you can say. It has a variable melting point. It starts at one point and it's end at the point. You don't have a particular fixed melting point. What is the melting point of steel? Anybody remember? Melting point of steel. See, these are the very simple question I'm asking. They will ask this kind of very simple question to you. Steel don't have any fixed melting point. You have to remember these things because steel is an alloy, no? Alloy don't have any fixed melting point. You have to remember this concept in mind. So I don't think so. You have learned a lot. You have learned a simple things in class. I don't know why. You should know these things. Very simple things. These are very simple things. If I'm talking about any alloy don't have any fixed melting point. They have a range of melting point, right? It will start and end. That's why they have a liquidus temperature and solidus temperature. Anybody remember this thing? Solidus temperature, liquidus temperature? You people remember the isomorphous phase diagram? Copper and nickel. You don't remember anything. Anyways, go and study right now. So if somebody will ask you what is the melting point of steel, just tell him steel don't have any fixed melting point. It depends upon the alloying element present. The amount of alloying element and the particular alloying element present will decide the melting point. If copper is there, its melting point will be different. If nickel will be there, the melting point will be different. If if chromium and nickel will be there, its melting point will be different. So it has a range of melting point, right? Anyways,
Sir,
yeah.
sir, will they ask in the interview that what is the solidus temperature of steel or only the definition of solidus temperature?
They will ask you, do you know what is solidus temperature? Actually, if you draw a iron carbon phase diagram, they can ask you, show us the solidus temperature, show us the liquidus temperature. You need to show them.
Okay, sir.
That's why I have sent you phase diagram. I think nobody have watched it. Recently, I have shared two important links, I think. One is related to phase diagram, one is related to maybe some particular topic. I told you this is very important for your interview. Nobody have watched it, I think. If you don't spend time on that, then how you can appear in interview? How you can expect they will select you? Your seniors didn't get placed because they know few things. They know a lot of things. They have answered very well in interview. They have prepared well. That's why they have selected in a large number. Don't think that a company will come and take 10 people, six number of people. It may not happen. They will simply take 1 or 2. If your performance is not up to mark, they won't take you, because there are a lot of institutes, colleges, renowned institutes are there. If they are performing well, then they will take more from there. They will not take from VSSUT. So you have to be prepared well before appearing for interview. Anyways, what was my question? Why pig iron melts at low temperature? Okay, where is... So pig iron melts at low temperature because you can just see the iron carbon phase diagram. It is clearly showing with increasing in the amount of carbon, the melting point will go down. And pig iron is having carbon now, right? So amount of carbon in pig iron is high. So that's why with increasing in the amount of carbon in the pig iron or in the carbon system, in the iron system, the melting point go down. That's why pig iron melts at very low temperature, as you told, some 1150 or 1200 degrees centigrade. But you cannot melt a pure iron at 1200 degrees centigrade or 1150. It will melt only at fixed temperature, that is 1538 or 1539. So this is the effect of carbon which is present in the interstitial sites, lower down the melting point. Anyways, what are the different strengthening mechanism? This is the very important question. What are the different strengthening mechanism? Somebody told me from third year, I think, he told me that he has did some project related to this production of new aluminum alloys, something he was saying. They have designed some new aluminum alloys. Why you are designing a new aluminum alloys? Maybe we want to improve the properties. You want to improve the strength, or you want to improve the hardness, you want to improve the toughness, or you want to improve the ductility, you want to improve both hardness and strength, or any impact strength, for example. So you need to know all the strengthening mechanism. This is very important. Anybody remember the name of, at least name of the strengthening mechanism? What are the different?
Sir, strain hardening,
Okay, fine, very
r-
good.
grain size reduction, solid solution strengthening, or precipitation hardening.
Okay, fine, very good, very good. So these are the basic things you should know. What are the different strengthening mechanisms? Because we metallurgy people work in an industry to enhance the property of metals, enhance the property of alloy. That's why we are working. So that's why you should have a proper knowledge on strengthening mechanism. What you can do, how you can play with the composition, how you can play with the proper microstructures, how you can play with the particular designing, so that you can improve the property, you can improve the strength. So strengthening mechanism is very important. The basic strengthening mechanism is, somebody has told, Shraddhanjali told, like we have precipitation strengthening, we have dispersion strengthening, we have transformation strengthening. Transformation strengthening is due to martensite transformation or bainitic transformation. Precipitation strengthening is due to presence of precipitates. Like in steel, we have precipitates such as precipitates of vanadium carbide, or maybe niobium carbide, or maybe some other carbides, or maybe some intermetallic phases. Fine. And we have dispersion strengthening. For example, dispersion strengthening is you are adding some foreign particles like TiO2 or ZrO2 or maybe Al2O3, alumina particles, into the steel. Then it will give rise to dispersion strengthening. They will remain in dispersed form. They are insoluble particles, fine, in the steel. Similarly, we have grain boundary strengthening. If you increase the grain boundary, the strength will increase. That is called grain boundary strengthening, or in other word, you can say grain refinement. We are refining the size of the grain. That means we are increasing the number of grain boundaries. We are increasing the number of obstacles to the motion of dislocations. That's why the strength is increasing. Similarly, we have other strengthening, solid solution strengthening. Solid solution strengthening is substitutional solid solution or maybe interstitial solid solution. Why, okay, do you remember why steel have high strength compared to pure iron? Why? You are studying physical, already you have studied physical metallurgy, you are now in final year, or now you are in third year. You can able to answer this question, simple question: why steel have high strength compared to pure iron? That is one of the reason we are making steel. We are not making only pure iron, we are making pure iron and converting into steel, right, during steel making process. Why? Can you
So
answer it?
due to tensile strength.
Due to tensile strength. This tensile strength is a property. I'm asking why, how the strength is increasing.
So due to the presence of carbon, like iron has Like no carbon content, but steel is a alloy of iron and carbon.
It is basically due to the solid solution strengthening.
Hello.
Sir, you were not audible.
Yeah. Actually, there is some problem with the internet in IIT today. I don't know why. Anyways, fine. So you understood my point. When you add carbon into the pure iron, the carbon will go into the interstitial voids. And the size of interstitial voids is small, but the carbon atom size is somewhat bigger. So it will push all the iron atoms surrounding it. It will create a strain there. It will create a strain. That strain will prevent the motion of dislocations. And when the motion of dislocation will be hindered, the strength will increase. That is called solid solution strengthening or interstitial solid solution strengthening. You should know these things. You should know what is dislocation. Then you might have a question, what is dislocation? If you can able to answer this, then that is very good. Anybody remember what is the dislocation? Anybody remember what is the dislocation? You don't know these things. How? This simple question they will ask you. As somebody have answered, missing of one line of atom. This is not one line. This is these atoms are arranged in a planes. Missing of half plane of atoms, you can say. Or it is extra half plane of atoms, some people say. Just shake it again. Huh? This plane of atom will move basically. Anyways, fine. Not discuss much about this. And okay, fine. Then difference between true and engineering stress strain diagram. This is very important question. They will ask what is the difference between true stress strain diagram and engineering stress strain diagram. You should know this. And you need to draw. Suppose they will ask you to draw for a steel. Draw engineering stress strain diagram and true stress strain diagram for steel. You should know all the formula also. Fine. Anybody remember a simple important point difference between engineering stress strain and true stress strain?
But in this strain, we consider instantaneous length during calculation, which is actually instantaneous means at that point what is the actual length. Actually, if you are a material undergoes a tensile testing, then it is start elongated and the dia or the length is reduced gradually. At that point, what is the actual length or dia that will be considered to calculate the true stress. Sir.
Okay, anybody remember what are the different important points in a stress strain diagram? Suppose I'm talking about engineering stress strain diagram. So everybody remember which axis is stress and which axis is strain? Anybody remember this simple question?
Sir, y-axis is stress and x-axis is strain.
Okay, fine. So what are the different important points in a stress strain curve?
So
Sir,
the
yield
yield
strength,
point,
ultimate strength,
Okay, you are talking about yield point and UTS, ultimate tensile strength point. Okay, anything else?
sir, offset region is also there.
Offset reason is a very good. Anything else? You have people miss something in the initial part.
Sir,
sir, making
But
proportional limit.
Proportional limit, very good. Proportional limit. Hmm. So if you go from the starting part, you have elastic limit. Somebody's writing. Okay, fine. You have proportional limit, elastic limit. You have a yield point. You have a UTS point, ultimate tensile strength point. At the end, you have a fracture point. That is called fracture stress. These are the important things you should know. Everybody should know. So if you draw a true stress strain curve, then after UTS, the the curve will not fall down. It will go rise. It will go up and up and up. But if you draw engineering stress strain curve, the curve will go down after UTS, because after UTS necking will happen, and you should know what is necking. Necking means there will be a reduction in the cross-sectional area of the specimen. While doing test, the reduction will be happening. The area, cross-sectional area will reduce to a large extent at a particular location where the stress is maximum. And finally, it will fail. It will become two parts. Okay, you need to check the formulas also. Huh? Those are very important. Formula for engineering stress, engineering strain, those are very important. Okay, what is formula for ductility? This is also very important. Ductility is very important. Anybody remember how to check that? Suppose I will give you a stress strain curve, and I will ask, can you tell me this material is having high ductility or low ductility by looking at the diagram? Can you tell me? Somebody is saying area under the curve. No.
Yes, sir, we can see by the graph.
Yeah, by the graph. How? Suppose I will give you two graphs, two unknown metal graph or two unknown alloy graph, and can you tell me which one is having high ductility, which one is having low ductility by just by looking at the graph? I'll not give you any other points. Just by look at the stress strain curve and tell me which one is having high ductility. This is the way you should
After
learn the
yield
thing.
points,
Sorry. Uh-huh.
after yield point in ductile material, there will be some lines. But in brittle material, the yield point is the fracture point. Sir.
No, no.
We
Actually,
will see
my
UTS
question, you didn't
in
understand my
ductile
question.
material.
My question was how you can compare the ductility of two materials. I'm not supposed to compare between the brittle material and ductile material. I'm asking both are ductile materials, but I want to find out which material is having high ductility. Just by looking at the diagram, just you can say simply just check the yield point and check the fracture point. Just check the yield
If
point and
the
fracture point.
fracture point will be more larger,
Yeah,
matlab,
obviously.
then it will be more ductility.
Exactly. You just check the yield point where yielding will start. Start from the yield point, goes up to fracture point. Measure it. If the length is more, that is having high ductility. That is measured by percentage elongation. You have to remember the formula for percentage elongation. In other way, you can say we can determine ductility by doing percentage elongation, by finding out the percentage elongation. It can be find out by using either length or maybe cross sectional area.
Yes, sir, reduction in cross-sectional area and increase in percentage elongation.
Yeah, yeah, very good. Fine, nice. Uh, what are the different methods to measure hardness and how hardness and hardenability is different? This is a question from heat treatment as well as physical metallurgy. What are the different methods to measure hardness? Anybody remember? These are very simple questions. And they will go into the depth. If you once answer this question, they will go into the depth. There are a lot of hardness.
Absorb
Sir,
Sorry.
Vickers hardness,
rock,
Brinell
rock,
hardness, Rockwell.
Sir, scratch hardness, indentation hardness.
Okay, fine. Yeah, there are many hardness methods. One is Brinell, one is Vicker harness, one is Rockwell harness, and they have different scales also. Like Rockwell A, B, C, and Vicker harness. This hardness actually depends upon can you define a hardness? They can sometimes ask you very simple question. What is hardness?
Sir, resistance to plastic deformation.
Okay, fine. This is very good. But then what is strength? Tell me. If you're saying resistance to plastic deformation, then what is strength? I'm not saying you are wrong, but you are missing some point. Yeah, Abhishek is saying something resistance to indentation harness. Okay, you have to remember. That's why I'm asking you to go through the videos. You will learn each and every point in details. Simple point in details. Okay, anyways, hardness means resistance to plastic deformation, but it is measured by indentation method. Fine. Unless until you do indentation, you cannot measure resistance to indentation. So hardness is nothing but resistance to indentation. Sorry, or you can say resistance to plastic deformation, which is measured by indentation method. But what is strength? Strength is nothing but resistance to plastic deformation, which is measured by tensile test, you can say, by pulling the material, not by indenting. Okay, fine. What is the difference between hardness and hardenability? This is a very important question. Hardenability, it is a very important property. If you're dealing with steel, you should know this thing.
Sir, ability to form martensite.
Very good. Ability to form. How easily you can form a martensite. If you can easily form a martensite, or susceptibility of a steel to form martensite, you can say, simply definition. If you can easily form a martensite, that means that is a more hardenable material, right? If you cannot form martensite easily, it is a less hardenable material. So hardness and hardenabilities are different actually, right? Or if a material can form martensite easily, that means up to a large depth also it will form martensite. But if a metal cannot form martensite easily, that means it will form martensite, but at the surface level. But if you go inside the material, at the center, towards the center, there will be no martensite. It may be perlite, it may be ferrite, or it may be mixture of perlite and ferrite. So this is the hardenability test. You might have done this test in heat treatment lab, maybe. That is called, what is that called? Quench test.
No,
Jomini
sir.
quench test.
Dominic quench test, yeah. From one end, you are cooling the sample to the other end, and you are checking the hardness from one end to another end. So where up to where martensite will be there, the hardness will be more. The where the martensite will be not there, the hardness will be less. That is a simple thing, no? That's why we are doing measuring hardenability. As I told, martensite is a very important phase in material, in steel mostly, huh? Okay, anyways, next question will be, what is CCT and TTT diagram? This is very important question. CCT diagram and TTT diagram, what is the difference? Can you draw a CCT diagram? Can you draw a TTT diagram? What is the difference between CCT and TTT? You just have a good knowledge on this. Just go through my videos, you will learn a lot. I have explained in a proper way how to start, how to draw, how to explain everything. It is there in the video. Even if you search in YouTube only CCT, my video will come. Just watch it. Anyways, I can answer it right now, but it will take too much time. It is a very broad topic. Okay, fine. Next, one important point I can discuss you that CCT diagram is more important because we are doing continuous cooling. In industry, we want continuous cooling. So that's why CCT diagram is more preferred in industry rather than TTT diagram. But TTT diagram will tell you everything in more details. It is a time temperature transformation diagram, right? CCT diagram is continuous cooling transformation diagram. And CCT diagram don't have Benite phase, but in TT diagram all phases will be there. It have austenite, it will be having perlite, it will be having ferrite, it will be martensite, benite, everything will be there. But in CCT diagram, benite phase will be not there because you are doing continuous cooling. And continuous cooling, benite will not form unless some alloying element will be there. Okay, anyways, why martensite is absent in iron carbon phase diagram? This is a very good question. Can you explain? What is the other name of iron carbon phase diagram? Anybody remember? Iron carbon equilibrium. Yeah. Yes, Sadanjali, you want to answer something?
No, sir. No, sir.
It is iron carbon phase diagram is also called iron cementite phase diagram. Fine. Or sometimes it is called iron carbon equilibrium phase diagram. That is actually accurate to say. Iron carbon equilibrium phase diagram, or it is better to say iron cementite phase diagram. Actually, it is not iron carbon because we are not considering 100% carbon. No, we are considering carbon up to 6.67. If you remember, everybody remember? We are not considering 100% carbon in one end. We are considering up to 6.67 where martensite will form. Fine. Okay, anyways, why martensite is not present in iron carbon phase diagram? Anybody remember this answer?
Sir, iron carbon diagram is a equilibrium diagram,
Very good, very good.
and martensite is a non-equilibrium
Non-equilibrium,
product.
non-equilibrium product. Very good, very good. Excellent answer. But
Sir, this is the very important drawback of iron carbon diagram. That's why
exactly,
TTT
exactly.
was invented.
Yeah, if you watch my videos, then only you can answer these questions. It is there in my video. I have explained it properly. What is the drawback? What is the limitation of CCT diagram? What is the limitation of TTT diagram? What is the limitation of iron carbon diagram? Everything is there. All the answers is there. You can watch it. Okay, fine. And you will feel confident after watching it. I am 100% sure from my heart. You will feel more comfortable and you will feel more confidence. Okay, anyways. Obviously, knowledge will bring confidence in any person. If you're knowledgeable, then you are always confident. You can face anyone. You have to remember this very important line. If you have knowledge, then you may look, I'm not saying ugly, for example, you may not look good in your opinion, but you will be confident wherever you will go. Knowledge always brings confidence within you. So learn as much as you can. Okay, fine. So next is, what is that? Okay, fine. Okay, fine. Somebody have told me martensite is not present because martensite is a non-equilibrium microstructure, but iron carbon phase diagram is the equilibrium phase diagram. Can you justify it further? Why iron carbon phase diagram is the equilibrium phase diagram?
Sir, it obtained at the slow cooling.
Very good, very good. If you take iron carbon system in from the molten state and you are cooling it very slowly, very slowly, then the phases come out, or the phases will form. They are equilibrium phases, like perlite is equilibrium phase, your ferrite is equilibrium phase, your ladybirite is a perlite is not a phase, a mixture of phase. Then similarly, ladybirite is a mixture of equilibrium phase. Ferrite, austenite, these are equilibrium phases, right? But martensite is a non-equilibrium phase. You have to cool the iron carbon system at a very rapidly, very fast. You need to quench it from the high temperature. Then only martensite will form. That's why martensite is a non-equilibrium product. Anyways, then further. Acha, what is phase diagram? This is also a very important question. Why we take 6.67% carbon only, not 100% carbon in the end of the iron carbon phase diagram? This is one of the important question from iron carbon phase diagram again. What is the phase diagram? And in iron carbon phase diagram, we are not considering carbon percentage above 6.67. Can you tell me? Phase diagram means what exactly it means? It is a plot between temperature versus composition, weight percentage, right? Like in iron carbon diagram, it is a phase diagram because in y-axis we have temperature, in x-axis we have weight percentage of carbon, right? But why we are not taking more than 6.67 carbon? Yeah, somebody is writing too much brittle, no use. Okay, very good. It's the right answer. If you take carbon more than that, already 6.67 carbon is very much more. It's more than sufficient in iron carbon system. If you add more carbon, it will become more brittle. There will be no use of the particular system because it is very brittle. No? It will crack easily into pieces. Within a small load also it will break into pieces because it is more brittle. So there is no use, there is no particular application of that particular system if you increase the carbon more than 6.67. But 6.67 carbon means it is cementite phase. Cementite phase is very important phase because it will give hardness to the material, it will give wear resistance to the material. Anyways, fine. What are microalloying elements? Do you have any idea? Microalloying elements? Nobody is doing internship in steel industry or steel plant or some designing of some steel. What is microalloying element in steel? You don't know. Microalloying elements in steel means steel is an alloy of iron and some other alloying elements. It may be carbon or maybe carbon with other alloying elements,
Sir,
right?
vanadium, novium,
Okay,
I guess.
very good.
I'm not
Vanadium.
sure.
Right. You are close to that, but microalloying elements mean in that particular steel, the amount of alloying element will be very less, in a very minimum amount. For example, vanadium, navium, they are added into the steel because they form carbides. They will form vanadium carbide, they will form navium carbide. They are very strong. They will give precipitation strengthening. So by adding a very little amount of vanadium, even if in a ppm level, ppm, parts per million, by adding a ppm level of vanadium. By adding a ppm level of niobium into the steel, you can increase the hardness and strength to a high level, very high level. You understood? No need to add in 1 weight% or 2 weight%. Just ppm level is enough. That will give you precipitation strengthening. And precipitation
Sir,
strengthening.
0.05 to 0.15%.
Okay, fine, you can say, but that's why just 0.05 is in ppm or what? If you convert it into ppm, 0.05 is near to the ppm, right?
Yes, sir.
Yeah, that's what I am saying. Like nowadays, the gold are microalloyed golds. That's why you can reach up to 24 carats. Otherwise, it won't be possible. 24 karat gold means it is highly ductile. You can press with your hand and with your fingers. You can change its shape. That's why earlier we are having 22 carats gold, where two percentage will be of copper or silver. But nowadays we are not adding copper and silver. We are making 24 karat golds nowadays, 23 carats, 23.5 or 24 carats, because we are adding alloying elements like vanadium, niobium in a very ppm or parts per billion ppb level we are adding, and it increases the strength. It is giving you maybe substitutional solution strengthening. It is okay. You understood my point, no? See how strengthening is very important. Okay, what is HSLA steel? High strength, low alloy steel. Same answer what I told. High strength, low alloy steel means alloying element will be very less in amount, but strength will be very high. The best example is addition of titanium, vanadium, niobium into the steel. They are high strength, low alloy steel. Alloying element amount is very less, but strength is very high. Can you justify what is the need of this microalloying element? Like it increases the strength, and what is the advantage of we are getting actually?
So it prevent grain coarsening.
No, 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 no. That is fine. Grain coarsening, it prevent grain coarsening means it will increase the strength anyway. That is one of the answer.
Yes, sir.
But my point is, what is the essence of this kind of microalloying element? They give precipitation strengthening, or they segregate along the grain boundaries and prevent the grain coarsening. What do you tell? That is also right. They form carbides, nitrates. These carbide nitrates precipitates along the grain boundaries, and they prevent the coarsening of grain. That's fine. What is the advantage you are getting?
Sir, maybe corrosion resistance.
Corrosion resistance. That is okay. Fine. The point is, these kind of steels are used in automobiles industry, mostly automobile industries, making car,
Sir,
bus.
gas extraction
Sorry.
in IOCL they are using in gas extraction
Okay, fine.
and
That's
oil
also good.
extraction.
Gas extraction, oil extraction. That's fine. No issue. My point is, if you add more amount of alloying element, what will happen to the density? Just tell me.
So density will increase.
Yes, density will increase to a large extent. If the density will increase to a large extent, already iron is having higher density. Do you remember the density of iron? This is a very important question. Let me ask
So
you.
7.87.
7.7 or 7.8 nearly. Okay, right. Fine.
Yes.
So if you add this vanadium, niobium, they are more denser than iron, right? If you add in a more amount, or if you add more alloying element, the density will further increase. And you want to make a automobile, then what will happen? Your fuel efficiency will go down, right? It will consume more fuel, right? We need a lighter vehicles. That's why similarly in for example, while making aeroplanes, we are adding copper into the aluminum. We are adding some very little amount of alloying elements like zinc, copper, magnesium, having low density, but it's added in a very little amount. Fine, they are lighter. Aluminum is already lighter, magnesium is already lighter, copper is high, density is high, but nowadays we are not using copper nowadays anyways. That is 2000 series aluminum alloys. Duralumin, you can say. That name is duralumin. You might know this one. Anyways, fine. What is maraging steel? That is the important question. What is a maraging steel? Do you people heard this name earlier? Maraging steel?
Sir, in heat treatment, basically low carbon martensitic steels are
Okay,
known
you
as
remember
marine steel.
something. Maraging steel means these steels are basically utilized in the defense sector. mostly defense purpose. Hmm. These are basically martensitic steel, but low carbon, as you told. That's right, low carbon martensitic steel. And the name is Mar aging. Mar for martensite. Aging means you are giving aging heat treatment. Right. The names come from Mar aging. Mar for martensite. Aging heat treatment you are giving. If you are giving aging heat treatment, then you will produce very small uniform distribution of precipitates that will give you very high strength. Fine. And low carbon means if martensite have high carbon, it will become more brittle. It will break easily. But if low carbon martensite, it is somewhat ductile, but give you more strength and toughness. Fine. These are very important questions and very important answers. You have to remember this. Okay, fine. What is aging heat treatment? Anybody remember what is aging heat treatment? Aging heat treatment will give you precipitates. Huh? You have to remember. Then you will get precipitation strengthening. But what is that treatment? And you remember? They might ask you, draw a heat treatment curve for aging heat treatment. Can you draw it? That's why I'm saying go through the heat treatment lectures also. Don't miss a single lecture. Watch it. You have enough time to prepare right now. At least you watch one video every day. While sleeping, while eating, or while roaming, you can watch it. You can listen it. Just listen it. Listening is enough. No need to make any notes. Somebody is saying solutionizing. Okay, Abhishek Naik. Okay, fine. Aging heat treatment means this is one kind of very good heat treatment where we can develop precipitates in the material. And precipitates, if you can develop, they will give you precipitation strengthening. The strength you can achieve to a very high level. Very high yield strength, very high tensile strength can be developed in a material by doing precipitation strengthening. That can be done by aging heat treatment. Aging heat treatment has few cycles. One is solutionizing. First step is solutionizing. Then second step will be quenching. And the third step will be artificial aging or natural aging, you can say. These are the three cycles. Just watch heat treatment lectures, you will understood more properly. Next, okay, what is the meaning of solutionizing? Okay, this is very simple. The first step of aging heat treatment is solutionizing. Solutionizing means you have a particular alloy, it already have precipitates, but those precipitates are very coarse, bigger size precipitates. It won't help you to give strengthening. You need very small precipitates, uniform distribution of precipitates, which you want. That will give you the strength. So if you do solutionizing, solutionizing means you are taking the alloy to a very high temperature, but it should not melt. So what will happen? All the precipitate will dissolve into the matrix. You will get a solution. You will get a solid solution. That is called solutionizing. Fine. Quenching means you are suddenly cooling from the high temperature to the low temperature, or to the room temperature, or below the room temperature. So that the every alloying element will be in solution form again. And last step is the aging heat treatment. Aging heat treatment means again you heat the alloy to a very low temperature. What will happen? Precipitate will start forming, but these precipitates are very small in size. They will prevent the motion of dislocation. Then the strength will improve. So initially you have coarse precipitates. Now finally you have very small fine precipitates and uniformly distribution of precipitates is there. Fine. Anyways, fine. We'll move to what is the difference between normalizing and annealing. This is a very simple question they ask. You need to remember these things. Huh? What is recrystallization? You have to remember. What is annealing of cold work metal? This is a very important question. What is annealing of cold work metal? Suppose a industry want to take you, want to give you placement in any rolling plant, hot rolling, cold rolling. They will ask this question. What is annealing of cold work metal? You should know this answer. A very good video is there available. You can just check it. What is recovery? This is also very important. I can explain it, but I think we don't have much time. What is hardness and what is hardening and tempering heat treatment? Difference between stress strain curve in mild steel and high carbon steel. What is creep? What is fatigue? What What is the effect of grain size on the property of material like steel and alloy? What is ferrite and austenite stabilizer? This is also again very good question. What is ferrite and austenite stabilizer? Anybody remember? Have you ever heard about this term? Ferritic stabilizer, austenite stabilizer.
Yes, sir.
Okay. Anybody remember any examples? In the gate, many times this question was there.
Sir, tungsten is an example.
Tungsten is an example of which stabilizer? Ferrite or
Sir,
um,
ferrite stabilizer.
okay, fine. Any other examples?
So silicon, chromium, vanadium, niobium, tungsten.
Okay,
These are the
fine.
examples of ferrite stabilizer, and cobalt, copper, and nickel are the examples of austenite stabilizer.
Very good, very good. Okay, fine. This, but do you remember why they are stabilizing particular phase? Suppose I'll take an example of, as you told, copper, nickel. Why they stabilize this particular austenite, not ferrite? This is in details I am going now. Since you have answered this, can you tell me why nickel and copper is austenite stabilizer, not ferrite?
So they have a FCC structure, crystal structure.
Very good, excellent. Because copper and nickel have face-centered cubic crystal structure, and austenite is also face-centered cubic crystal structure. So that's why same kind of structure is stabilizing the same. Fine. Similarly, but there is some exception. Fine. Cobalt is HCP, but still it is stabilizing. You are saying austenite. Similarly, silicon. What is the structure of silicon? You remember? It is neither FCC neither BCC. It is having some other structure, diamond cubic, or what? Anybody remember what is the structure of silicon? Is it diamond cubic or something else?
So diamond cubic.
Very good. You need to draw. They can ask you in the bark interview. If you are selected for bark interview, they'll ask to draw. They'll ask what is the structure of silicon and draw the diagram of the crystal structure. This is also very important. You should know all the crystal structure diagram. BCC, FCC, HCP, and any diamond cubic structure. You should know. Fine. Okay. Anyways, even if silicon is diamond cubic structure, but it is stabilizing BCC because ferrite is BCC. Right? There is an exception you have to remember. But if you check tungsten, as you tell, chromium, tungsten, molybdenum, these are basically BCC. They stabilize the ferrite. Okay. Anyways, you know these things. They're a very important question. And what is cementite? You should know. What are the different type of steel? You should know. What are the different type of steels? Like carbon steel, we have alloy steel, we have plain carbon steel, and we have alloy steel. We have different alloy steels also on the basis of application, on the basis of composition, right? You just need to check it. And carbon steel, we have different kind of carbon steels, like low carbon steel, medium carbon steel, high carbon steels, mild steels, right? You should remember the carbon percentage also. You should remember these things. What is stainless steel and what are the types? This is also important. What is stainless steel? Somebody was talking about uh, boiler, right? Boiler is made up of this kind of stainless steels, or the boiler pipelines. They are also made of this stainless steels kind of thing. What is solidus temperature, liquidus temperature, solvus line? You should know this thing. What is a solvus line, solidus line, liquidus line? In a phase diagram, you should know. What are the different series of aluminum alloy? As I told, this you should know. You can watch my videos, it is there. What are the different series of aluminum alloy? Like 1000 series, 2000, 3000, 4000, 5, 6, 7, 8. Now 9 series is also coming. What are the principal alloying element in those series? You should know. What is cold working versus hot working? You should know. What is strain hardening? You should know. What is carburizing nitriding? You should know. What is toughness and fracture toughness? What is the difference between toughness and fracture toughness? You should know. What is the melting point of steel? Melting point of copper, aluminium? You should know. What is the difference etchants used in the steel and aluminium metallography? You should know. Anybody remember what are the etchants used for aluminium metallography? What is the name of that reagent?
Sir, picric.
I'm talking about aluminium. Kahler's reagent, Kahler's. You have to remember. This is a very important question. Kahler's. It is a mixture of various acids, nitric, hydrochloric acid, hydrofluoric acid, like that. Huh. Hydrochloric acid, nitric acid, and distilled water will be there. But if you're talking about steels, then we are using nitals. Huh. 2% nital, 3% nital, 5% nital, it depends. You remember the composition of nital? It will have ethanol and
So nitric acid and ethanol.
yeah, nitric acid, nital. The name itself is saying nital means nitric acid. Al means ethanol. Don't mug up the things. Just remember the things. Nital. N for nital. Nital means nitric. L means alcohol or ethanol. Fine.
Yes, sir. 3 to 4% nitric acid and rest is ethanol.
Okay. And different types of nital. Na, I told you 2%, 3%, 5%. It depends upon the requirement. Concentration of nitric acid will change. Okay. Anyways, what is inclusion and what is hot and cold shortness? This is very important question. What is the inclusion? What is hot shortness and cold shortness? Have you ever heard about these terms? Hot shortness and cold shortness?
Sir, I had a little idea about cold and hot. Like cold and hot shortness are their casting defects uh, in the gating system when a pouring in the mold. If it is too hot, then it is hot shortness, I guess, and reverse is cold.
No. This is not a casting defect. It's a defect when you are doing rolling. This comes during casting, but when you are rolling, there is a issue. Suppose it actually basically happen in the steels. Sometimes people call this steel suffers from hot shortness, this steel suffers from cold shortness. If you're sitting for any steel industry, they may ask you this kind of question. So you have to remember, anybody remember the composition of pig iron? I'm not asking about the particular composition, I'm asking about what are the impurities present. Anybody remember? Silicon, carbon,
Manganese,
manganese, phosphorus, sulfur.
sulfur.
Anything else? Carbon, silicon, manganese, phosphorus, sulfur. These are the elements, right? So if while making steel you have excess sulfur in it, then maximum chance is that while hot rolling, the steel will get cracked along the grain boundaries. That is called hot shortness. Why this is happening? Because if you have excess amount of sulfur in the steel, sulfur will automatically react with iron to form iron sulfide. And iron sulfide is a eutectic compound. What is the difference between normal compound and eutectic compound? Do you know? Any idea you have? It have low melting point. A eutectic compound means it will melt at a low temperature. Right. So now you have steel containing iron sulfide. They are segregated along the grain boundaries. Fine. And you are doing hot rolling. Hot rolling means, do you have any idea about hot rolling? Anybody idea on hot rolling, at what temperature we are rolling the steel? Doing hot rolling. Hot rolling simply means you are rolling above the recrystallization temperature. Fine. This is the definition. But at what temperature? Nearly maybe 950,000 degrees centigrade. Fine. So 950,000 degrees is very high temperature. Fine. So at that temperature, this iron sulfide will melt. Why? Because they have low melting point, but iron will not melt. And they are segregated along the grain boundaries, right? So melting will happen along the grain boundaries. So while rolling, hot rolling, it will crack. Your entire steel will get cracked because of this hot shortness effect. Fine. I think it is clear, right? Similarly, cold shortness means if you have more phosphorus in the steel, it will form iron phosphide. And iron phosphide is brittle in nature. And if you're doing cold rolling of the steel having iron phosphide in it, then the cracks will be happening because it is brittle in nature. Iron is ductile, but iron phosphide is brittle. The stress concentration sites will be along the iron phosphide. It will break. I think it is clear, right? For better understanding, you can go through the YouTube lectures. Huh? Everything is explained properly there with diagrams also. Okay, these are the important questions in my point of view. Maybe I missed few other questions. We can discuss it later if or if you have any questions you can ask me, or if you are going through the books or videos, if you have any questions you can ask me later. I think we have a long discussion.
Yes, sir.
Third year, if you want to ask any questions from your side, you can ask me. If you want to ask later also, you can ask me, you can call me, you can text me, no issue. Just take my number from class representative and you can call me or text me. Finally, if you have any questions you can ask me right now up to this. Okay, fine, then there is no questions further.
So there is a question that from a junior basically.
Okay, okay, fine.
If a student is interned in a ferroalloy company or
Okay, okay, fine.
forging related company,
Mm-hmm.
how he or she should face interview in front of the interviewer, because most of the steel and aluminum companies are visiting.
Okay, fine,
Like
this is very
IMPA is
good
very
question.
rare.
Okay, okay, fine. This is very good question. For him or her, I'm saying ferro alloy is the heart of steel making company. If there will be no ferro alloys, then there will be no steel at all. So this is a positive side. This is a positive side. What I'm saying, wherever you are doing internship, do internship properly, spend more time, learn more things, ask questions, clarify your doubts, do make a note of it. Everything should be clear, and it should be on data based also. Wherever you are doing internship, put all the data, like what is the temperature, what is the composition, what is the percentage, everything you should remember these things, right? So there is no issue. If you, even if you are doing internship in ferroalloy, it will give you benefit. There will be no loss, because ferroalloy. Okay, fine, can I interact with him? Who is that particular person? Hello, I don't know who is that guy, or hello, am I audible? Hello, am I audible?
Yes, sir, you are audible.
Yeah,
Yes, sir.
who have
Hello?
asked this question? Huh? This.
Sir, it was asked by Aditya Kiran Patnaik from pre-final year.
Oh, he's not there here or what?
I think there is network glitch due to which he is
Okay,
not
okay, fine.
available right now.
Guys, this is a very important question in steel making. They might ask you what is a ferroalloy and what is the application of ferroalloy in steel industry. Today I'm not going to discuss much, but this is a very important question. Ferroalloy is the heart of, as I told, for a steel plant, because without ferroalloy you cannot imagine steel. Ferroalloy is mostly used to deoxidize the steel. Deoxidize, because while making steel you have lot of dissolved oxygen, right? And you want to remove this dissolved oxygen because they are very detrimental for the property. They may give rise to casting defects, they may give rise to oxidation problem, like bad appearance and all. So you need to remove the dissolved oxygen. So you need ferroalloys. Ferroalloys will remove the dissolved oxidation. That is called deoxidation practice. So during deoxidation practice, we add ferroalloys. And also ferroalloys help you in addition of alloying element. Suppose you want to add any kind of alloying element like tungsten, chromium, nickel, vanadium, niobium, silicon. They are added in form of ferroalloys, not in virgin form, right? So these are the two important points about ferroalloys. So ferroalloy plant is good. If you have good knowledge on ferroalloys, that is good also. Anything else you have to ask? Pre-final
Sir,
years?
a question from a junior,
Okay,
Aditya Kumar.
okay, fine.
That it's a basic question, sir. That in the field of metallurgy, how
Mhm.
many is there any scope other than steel and aluminum plants?
In core companies, he's asking. Yeah, we have copper plants also. Like Vedant, Hindalco and Vedant, they have copper plants also, I think. I'm sure. In Rajasthan, your senior, one of your senior, Bibek Sahu, he's in copper plant. He got placed from VSHUD itself. They have given posting in copper plant also. It is in Rajasthan. He's doing very well there. But he's trying to come to steel industry because he want to do job in Odisha. He was asking for recommendation to me recently, but he's doing great there. He's a good student also. He's a very sincere student. I know him. So you can go also
Sir,
get placed. Uh, then
sir,
there is also,
Adani
yeah, yeah. There is
is
certain.
copper.
Mhm.
Sorry,
Okay,
sir. Sorry, sir.
yeah, you
You
are asking.
complete
Yeah,
your.
you are asking something. Okay, you can ask.
Yes, sir. I was asking that Adani KCL, the Kutch Copper Limited, is a copper-based company, I think.
Maybe I'm not sure about that. You can check it properly. I have no idea about that. Maybe.
Sir, I could ask Aditya to ask you his questions
Yeah, yeah,
if he
Aditya.
is present over here.
Mhm.
Aditya, I think he is not available, sir. We
Okay, fine.
will proceed.
Okay, okay, fine. Actually, in metallurgy, there is lot of opportunities, but the point is, you should have a sound knowledge. I'm saying many times, if you, because competition is high nowadays, because a lot of institutes are having metallurgy nowadays. IITs, NITs, they have already, and state colleges are, a lot of state colleges are there. A number of seats have also improved. Whoever got placed in from VSSUT, they, actually they have prepared very well. That's why they got placed. So similarly, I am asking you people, you please start preparing from now. Don't wait for last, because there are a lot of things to prepare. And at least you should know everything in details and with data, as well as you should know basic things. Basic.
Yes,
So
sir.
my point is, after finishing your internship, you can spend 2 days about writing your questions from internship. You prepare the questions by yourself. Suppose I'm doing internship in for example in cast house, for example. So I will prepare my questions. What are the defects in the cast material? What are the defects in the roll material, for example? How the defect looks like, how to identify the defects. I will prepare questions from my side. What is the melting point of the alloy coming from the furnace? While pouring, what is the temperature? How they are removing inclusions in the cast house? Are they doing continuous casting or are they doing batch casting? So what kind of process they are using? What is the yield? And what are the composition of the alloy they are casting? So I will prepare many questions. What is the parameter? Everything I will prepare questions and I will answer myself. Or if I cannot able to answer myself, I will ask the people working there. So in this way, you can prepare well for your from your internship part. So spend 2 days after completion of your internship. I mean, while you are there only, spend 2 days for writing questions by yourself. Ask yourself what may be the questions, and write the answer also by asking them or from internet, or you can ask me. Whatever is possible, you can do it. That's the best way to prepare from the part of internship. Simple questions, any simple questions. Suppose somebody is doing in a pot line. So what is the dimension of pot line? What is the length? What is the depth? What is the width? What are the number of carbon anodes they are using? What is the size of anode? What is the composition of anode? Right? How they are welding the anode with this aluminum? Right? How much electricity they are using? How much voltage they are using? What is the efficiency of the each pot? Fine. What are the defects happening in the pots, like what is that called, anode effect? How they are solving the anode effect? How many, after how many days they are changing the anode? Is the anode consumable or non-consumable, for example? How much CO2 is evolving? What is the what is the fume treatment plant? If somebody is doing in fume treatment plant, what is the fume treatment plant? What is the that what are the bag made of? Right? What is the capacity of that bag? What are the solid particles obtained from that bag after cleaning? What are the gases generated after the cleaning of the particles? So these type of question you need to ask yourself and make questions and make answer by yourself, or you can ask the colleagues, your mentors, to me if you want.
Sir,
Yes.
sir, can you please tell us what are some questions related to cast house in aluminium industry?
Already have told you in the
Or
already have told you, right? Like for example, in cast house, you the first question will come into your mind is it is continuous casting or batch casting. If it is continuous casting, then what is the process they are doing? What is the stages of the process they are doing? Like they have a teaming furnace or teaming ladle. They are hitting the molten. They have a heating furnace. They are bringing the molten metal from heating furnace to the teaming ladle. They are pouring it. After pouring, the metal will flow in the channels. Then there will be a filter. I think you have seen all this thing. I think. Are you in continuous casting?
yes. No, sir,
They
batch
are
casting.
filters. They are filters.
Yes,
They
sir.
will remove the inclusions. Then
Yes,
the
sir.
aluminum will flow out, and finally it will pass through the two rollers, and it will form a coil, right?
Yes, sir.
Yes, sir.
So you need to remember what is the capacity of that particular furnace. What is the at what temperature they are storing the molten aluminum alloy, like 750 or something, and what is that particular inclusion cleaning system? What is it made up of? Tibal, I think. Tibal they are using, right? What is the composition of tibal? Fine. Then what is the dimension of that particular channel? Huh. And what is the thickness of the coil they are making after continuous casting? Right? What is the dimension of the roller? In between the roller, the molten metal will pass. What is its dimension? What is the diameter or radius? Fine, these things you should know. And what are the defects? That is very important. After rolling, after making coils, they have some defects. What are the defects? How they are forming? What is the name of the defect? What is the diagram of the defect? How they are forming? What is the solution to that? Also, that is very important. You should have a question, and question should have a solution in terms of how and what, and how you can solve it. Right? These are the things. If a coil
And
will
sir,
get, yeah,
uh, and the other question that the other than GATE, what are some exams where we can apply?
yeah, as I
What
told, bark you can
exam?
apply. Bark, bark is taking in two way. Either you have a good gate score, otherwise you can appear separately for bark exam. There will be written exam for bark, and you can face the interview. But if you qualify gate with a good score, then you can directly go for interview. So bark is good. You will become a scientist after BTech. If they will give 1 year in training, then you will become a scientist. Then other exams are like they have a lot of PSUs. But they are taking through gate like sale exams. Sometimes sale will do exams separately. Sometimes they are taking through in gate exam. So gate exam is very important if you want any PSUs like sale. uh, Steel Authority of India Limited. There are a lot of plants are there. Similarly, we have in Andhra Pradesh we have a plant, Vizag Steel Plant. They are doing exams separately. There is on the other small PSUs are also there. I don't remember exactly. In railway, there is an exam. You can check. That is Mini Ratna, I think. I forgot the name. BIS also is taking Bharat Indian Standard. Sorry, what is BIS exactly? Do you remember? BIS, Bureau of Indian Standard, right?
The Bureau of Indian
Bureau of Indian
Standards.
Standard, yes. So, but the vacancy will be for one or two people maximum. Right? So that is also you can go. You can also, if you want to do research after BTech, if you have good CGPA over 8.5, you can apply for IMMT, Institute for Minerals and Materials Technology, Bhubaneswar. You can apply for NML also. You'll become a scientist. There is a facilities there. Sometimes after MTech they are taking, sometimes after BTech they are taking. I don't know exactly. Nowadays maybe after MTech they are taking. BTech I'm not sure, but you can check it. It is there is a provision, and there is a lot of other exams also. Lot of PSUs are there. Nalco, fine. Nalco is also, but Nalco is taking through GATE exam, I think. So GATE is very important if you want to go in PSUs.
Yes, sir.
You can go for
Sir,
higher
in
studies.
rolling process,
You can,
there is a question from Amarnath.
okay, fine.
In rolling plant, How? What type of interview questions will be asked?
In rolling, in rollings, as I told, what is the difference between hot rolling and cold rolling? I told you, no, what is the difference between hot rolling and cold rolling? Then they may ask you simple questions: what is recrystallization temperature? What are the factors affecting recrystallization? What is recovery? What is annealing of cold work metal, right? And at what temperature they are doing hot rolling, exact temperature, at what exact temperature they are doing cold rolling, and what is the stages of hot rolling, right? Because they are in hot rolling, they have many stages, right? They are cleaning, they are heating again, they're rolling, then again they are heating, again they are cooling, they're spraying water on it to remove scales. There are a lot of, you need to remember all the stages. Each stage, what is the role of each stage? At the end also they are giving some oils, grease, to prevent corrosion oxidation, or it will decrease the friction also, right? Many things are there. And what is the parameters, like what is the rolling pressure, what is the dia of that particular rolling machine, what kind of rolling machine they are using, planetary rolling machine or simple rolling machine. Hmm.
So in case of aluminum
What are
uh,
the defects, what are the
plants,
defects in the rolling? After rolling, what are the defects you are getting, how to solve these defects so the defect will not come. Okay, what you are asking? Yeah.
sir, sir, in the case of aluminum plants, the rolling is different or same like the steel industries?
The process they are doing is 80%, 70, 80% same. The process, the steps mostly. But the point is, because they have different properties, they have different ductility, they have different hardness. So parameters will be different. Like rolling pressure will be different. Obviously, rolling pressure will be less for aluminum, but rolling pressure will be high for. Similarly, temperature. Aluminum you need to heat up to maybe 550 or 500 for hot rolling. Maybe for steel, you need to go to 1100 degrees centigrade or 1000 degrees centigrade, right? So parameters will be different, conditions will be different, but process will be nearly same. Same recrystallization will be working in that. Hmm. Recovery, recrystallization, grain growth. These are the two important phenomena, three important phenomena happening. You should know what is recovery, recrystallization, grain growth. That's why I'm asking, go through my videos. You will learn a lot. You learn very, very simple things in a easy way. Just spend 1 to 2 hours daily, and it will be enough for you. No need to make any notes also. Just watch it, listen it enough. While having dinner or lunch, you can also use a earphone and listen it. That will be also enough for you. You can consult your seniors. They will tell you, they have a good experience. So they will explain you how important those videos are. Okay, any further questions?
No, sir, no more questions. It was a great session with you, sir, today.
Thank you for your kind words.
It was really a good experience with you, sir, today. Like we spent 2 hours and it was really fruitful for us in the interview.
Thank you, sir.
Okay, guys, thank you so much for joining and learning a lot. I hope you all get placed in a good company and make a good career, definitely.
Yes, sir.
If you have any doubts, you can call me directly. There is no issue. I told you many times. I'm there to solve your doubts, solve your issues you have. I'm not there right now, but still I'll try my best. I am busy with my PhD, but still I'll try my best. Okay, guys, good
Yes,
night.
sir. Good night, sir. Thank you.